today, everyone will be able to get all 9 points on this. Okay, so the first question asks, find the coordinate of the position of the particle at t equals 2. So what is it asking us to do? Okay, so we're given an initial condition. At t equals 1, the particle is at 3, 5. Okay? So remember, this is an xy coordinate. This is a t coordinate. So you have to be careful when you're doing that. So we're trying to find where it is at t equals 2. So since we know where it is at 1, we're going to start at 1 and go to 2, and we're going to integrate cosine t squared dt. And what do we have to add to that? What? 3. Does everybody understand where the 3 came from? We're all good? Okay. Can somebody give me an answer? 2.556. Now, the other thing some students are still doing is not rounding to 3 decimal places. I won't know if you don't do that, but I will feel it. And I will come and I will hunt you down. You need to go to at least 3 decimal places, people. You don't want to lose a point over something as ridiculous, can I use that word, as not going to 3 decimal places. Yes?
I already like 6. Is that okay?
The best thing to do is to write everything your calculator says.
Okay.
Just give it a calculator dump. Whatever your calculator says, write it all and move on. Okay? That's the best thing to do. Okay. How many points do you think this was worth?
2. I'm going to go confident 2.
1 for the integral. That's correct. 1 for that 3. 1 for the integral. 1 for using the initial condition. And 1 for the answer. And we want to remember that our answer needs to be 3 decimal places. This answer was okay, and they also would have accepted 2.557. But the biggest thing is go 3 places behind the decimal. We've said that all year, and I have been trying to penalize you if you didn't on the test so that you would remember. Okay, there's a point on the curve at which the line tangent to the curve has a slope of 2. At what time is the object at that point? Okay? How do we find the slope of a parametric? Okay, so dy dx, which is our slope. Dy dx is our slope. It is not velocity. That's not velocity. So this is dy dt over dx dt. And since we were given dy dt is e 0.5t, and dx dt is cosine of t squared, we want to know when is this equal to 2. Now, what's the best way of doing this? Calculator. That was one of the things they said on this question, is a lot of students could not use their calculator to solve this. Can you use your calculator to solve this? If you cannot, please come see me. I will love to sit down and show you how to do it, okay? If you struggle doing this, you need to come see me. So then we get t is equal to 0.840. How many points was that worth? 2. Where does the point come from? Okay, 1 for the answer. And 1 for dy dx. Very good. Okay, we're all good? All right, C, find the time at which the speed of the particle is 3. So this just required us knowing the formula for speed of a parametric. What's the speed of a parametric? Okay? Because, ladies, speed is just magnitude. So it's the x prime component, y prime component. And all we had to do was take what they gave us and set it equal to 3. So here's another place where students couldn't do it just because of calculator issues. What would be the best way to do this on the calculator?
The pattern line one, and let's say, and then try to.
Find the intersection? Okay. Typing this in, I think the hardest part about this is going to be typing this in. You have to know when you do a square on the calculator, you have to do it like this. Cosine, parenthesis, t squared, close parenthesis, squared. You have to put this like this in your calculator. Okay? And that would be, okay. And that ended up equaling 2.196, and it was worth 2 points. You got one for the point of, you got one for the formula and one for the answer. What do we have to remember? Speed is not slope. Speed is not slope in this case, okay? The speed, the velocity is the derivative of, the x and the y components, but it has to be written as a vector. Velocity is not slope on a parametric. Yes? That's on a rectangular function. You don't have to do the absolute value here because technically if you square and square, you're going to get a positive and then take the square root. This will always be a positive answer. And then the distance is simply arc length. So the distance would be from 0 to 2. Again, cosine of t squared. If you want to get in the habit of writing like this, so that's how you put it in your calculator, that's fine too. Sorry, from 0 to 1. Okay, and that was worth 2 points. All righty, questions? Any questions? Yes, Tony. Speed? Not in a parametric, because in a parametric, the speed is the arc length, and this is the formula for arc length. And also, like I said before, this will always be positive. Well, I guess that doesn't have to always be positive since we're taking the area on the curve, but unless we did something weird like go from 1 to 0, that would be positive always. You do the absolute values for total distance if it's in rectangular mode. So like if I give you, yeah, what do you mean you've never seen it? You wouldn't use this formula on a rectangular graph. You only use this formula if it's parametric. All right, any other questions? Okie dokie.